There it is, the bridge of death.
Who is that?
That's the bridge keeper. He asks you 5 questions.
3 questions.
Yes, 3 questions. He who answers the 5 questions.
3 questions.
Yes, 3 questions may cross in safety.
And what if you get them wrong?
Then you are cast into eternal peril. Now, who shall go first? How about Sir John?
I have an idea. How about Sir Daniel?
Yes, Sir Daniel, you go.
All right, I'll go.
Stop! Who should cross the bridge of death must answer me these questions 3 ere the other side, ye see.
Ask me your questions, Bridgekeeper, for I am not afraid.
What is your name?
Sir Daniel of Chile.
What is your favorite butterfly?
Monarch.
What is the derivative of x cubed plus y cubed equals 18xy?
So this problem must be solved implicitly because the y is caught up in everything. It's not by itself. And in order to do that, you must implement a dy dx every time you differentiate y. So you would take the derivative of each individual part, and then you must get the dy dx on the same side and factor it out so you can solve for it. Then you just simply solve for dy dx, and then you simplify it which you can, leaving you with 6y minus x squared over y squared minus 6x as your final answer to the derivative of x cubed plus y cubed equals 18xy.
Well done! You may pass.
Oh, that was easy.
Stop! Who should cross the bridge of death must answer me these questions 3 ere the other side, ye see. What is your name?
Sir Daniel of Israel.
What is the second derivative of x cubed plus y cubed equals 18xy?
Thanks to Daniel's work, we already know that the first derivative of this equation is 6y minus x squared over y squared minus 6x. Now, we just need to find the derivative of that expression. We will again need to do this implicitly using the quotient rule. We multiply the bottom by the derivative of the top, and again we have to attach dy over dx when we derive with respect to y. Then subtract the top times the derivative of the bottom, all over the bottom squared. We can then substitute 6y minus x squared over y squared minus 6x in for dy over dx. Then all that's left to do is to simplify. We get our final answer as negative 2xy times 216 plus y cubed minus 18xy plus x cubed all over y squared minus 6x cubed.
Correct. Aye, but what is your favorite butterfly?
The Actius Luna.
That's a moth!
No!
Stop! Who should cross the bridge of death must answer me these questions 3 ere the other side, ye see. What is your name?
Sir John the Suitcase.
What is your favorite butterfly?
The peacock pansy.
Aye, but given this equation of a particle's position, where s equals meters and t equals seconds, what is the particle's velocity when t equals 4?
Velocity is the first derivative of position, so to get the first derivative, you use the power rule to get 4t cubed minus 6t squared minus 12t plus 9, and when you plug 4 into the time, you get the velocity at 4 seconds as 121 meters per second.
That's correct!
I know.
Stop! He who must cross the bridge of death must answer me these questions 3, ere the other side he see. What is your name?
Sir Walter Raleigh.
What is the derivative of this equation?
Y equals sin x plus e to the power of 2x plus the natural log cubed of cosine x. This means that this equation is explicit. Now I must find the derivative of this equation. Now I must use trig derivatives to find sin x, which would be cosine x. And to find the derivative of e to the power of 2x, I must use e rule, which would make e to the second x 2 times e to the 2x. Now to find ln cubed cosine x's derivative, I must use chain rule and natural log rule, which would mean that first it will be 3 times ln squared cosine x times 1 over cosine x times negative sine x.
That's correct! But wait, what is your favorite butterfly?
Well, what's yours?
The evergreen bagworm, of course.
That's a moth!
But what the ah!
The Holy Grail! Oh. Calculus. Ah. Now what? The Holy Grail. He asks you 5 questions. 3 questions? Yes, 3 questions. He who answers all 3... That's the bridge keeper. He asks you 5 questions. 3 questions? Yes, 3 questions. He who answers the 5 questions... 3 questions...
1.
John winked at me. I had to.
No, okay.
1. Go.
There it is. He who answers the 5 questions... 3 questions? 3 questions may cross in safety.
Oh, stop. We should cross the bridge at 3.
1.
Stop!
2, 1, go.
Stop! Who should cross the bridge of death?
Sir John, the super...
No!
I wasn't
Wrong.
of a position of a particle with S in meters and T in time.
Are you kidding me?
Equation
Of a particle in motion. That's not right.
Of the...
given this equation of a particle in motion, but given this equation of a particle position, what with T in seconds and M in